sharing your Monday with us. So this presentation it's an overview presentation. I will not advocate for specific standards or targets. Rather, I'm advocating for an evidence-based process. So we all know the issues, the problem with single-use plastic. These are, I guess, the latest news on single-use plastic. This is as of January 21. 75 countries have introduced bans on lightweight plastic bags, while 36 countries impose a charge on per bag. As was announced in the news just last Wednesday, SWS ran a survey which said that 7 out of 10 Filipinos are okay with a nationwide ban on single-use plastic. But it's interesting that you should note these specific single-use plastics that were mentioned. So it's the Lapo bags, so those thin plastic sheets, styrofoam, polystyrene, sachets, carton packaging, which is not really plastic, but you have the toy bags, various utensils and so forth. And then also late last week, Senator Villar announced, it was announced in the newspaper, that the Senate will be considering a ban on single-use plastic. So the objectives of this legislative forum is to help clarify what is the range of products covered by single-use plastics. Second, to discuss strategies for the phase-out of single-use plastics. Third, to discuss strategies for the management of all types of plastics. And fourth, very important, to encourage a multi-sectoral strategy on plastics. So this presentation will have 3 parts. First is just for us to understand what the nature of plastics. Second, tackle the single-use plastic problem, and then propose strategies for the management of plastics. So, plastics. We all use plastics. Plastics are polymeric materials. Most plastics are made from coal and petrochemicals. And plastics have a diverse range of properties by material design. That's why they're so useful. But the recyclability of plastics varies. Some plastics are not recyclable, and only a few of the plastics are biodegradable. Now, these are the basic materials of plastics, which are polymers. And as you can see, there's a long list of polymers used to make plastics, and this is not even a comprehensive list. So we're dealing with many types of materials, each designed for a particular purpose. Now, you've seen these recycling marks. Unfortunately, the Philippines does not use these recycling marks. They're used in other countries, but for some reason we have not adopted them. But even these 6 types of plastics, which are recycled, there are only 6 of the long list that you saw in the previous slide. So these 6 are supposedly recyclable. You have the PET bottles, high-density polyethylene, polyvinyl chloride, low-density polyethylene, polypropylene, and polystyrene. There's a number 7, but number 7 is actually a really long list of other polymers. So you put it in this bag, and it's so many other types of polymers. And then there are those which are not recyclable. Included here would be the thermoset plastics and non-recyclables. So when we talk about recycling plastics, we're really just talking about a select list of plastics that can be recycled. Now, to make plastics, you just don't take the polymers, you have to add stuff to it to make it functional. Some of these functionalities that you need would be, for example, you have to add flame retardants. Some of these polymers are flammable by themselves, so you add material to make them resist, just going up in flames. Or you can add things to prevent them from being degraded under light, UV light or sunlight, and many other things. Also color. Plastics would be colorless. So you want colored plastic, you have to add stuff to it. And if you look at the total, and this is not a comprehensive list, there are 26,000 additives that are used in plastics. Now, so these chemical additives add properties and functionality to plastics. That's why plastics are so useful. But the additives are not declared in the plastic products. So you see a plastic material, they don't say what's been added to it. And then many of these additives, unfortunately, have not undergone toxicity testing. Toxicity testing is very expensive, and you can't imagine that they've tested 26,000 materials. So many of them have not undergone toxicity testing. The most well-known of these additives would probably be the phthalates, which are endocrine disrupting compounds, and maybe the bisphenol compounds. But that's only two, or actually there are many types of phthalates. There are only a few of the 26,000. And so the reuse, recycling, and disposal of plastics must be done with knowledge of the additives. Because some of these additives are harmful, you don't want to just burn them or do whatever, because you'll be releasing these additives. Now we'll talk about plastic pollution, and macroplastics will be the plastics that you see visually. So you have the bags that float in the oceans, as well as tires. Tires are actually classified as plastics. And then they'll degrade into microplastics and then nanoplastics. Unfortunately, all plastics will eventually degrade into microplastics and nanoplastics. It's inevitable. And the microplastics that are detected now in fish and stuff may have been discarded 20, 30 years ago, and now they're microplastics, and they'll soon be nanoplastics. So it's, I guess it's a difficulty or a consequence, something that was not foreseen, but something which we are quite aware of now. But in addition to the plastics, you have the fibers. Now these fibers will include polyester, nylon, and acrylic. All of us here wear some fiber that's got plastic in them, or synthetic fibers. So polyester, cotton, you have the polyester part, and then all of these dry fit and spandex, lycra, are also plastic. Rubber shoes that are popular now are all plastic. So, it's an unfortunate thing, I guess, something that, which we don't have a solution for, is that microplastics are really in the environment, and I don't know what really we can do about it, except, I guess, monitor them. So, so that's the nature of plastics. Now let's try to tackle single-use plastic. Now I've grouped all plastics into two major groups. You have single-use plastics, and then you have the durable plastics. So right now we're just tackling the left side, single-use plastics. And here I've grouped 4 types of single-use plastics, and there may be more depending on what you see. You have the thermoplastics, which includes the grocery bags, packaging, food packaging, bottles, straws, cups, personal hygiene materials, diapers and stuff. Medical packaging would be thermoplastic. You have the laminates, sachets, cosmetics, pharma, and others. Then you have the thermosets, which are non-recyclable, and some of them are single-use. And then you have bioplastics, which are sometimes covered in the news, but they're really not available, at least not on an economic scale. And then you have the durable plastics, which would include durable fibers, engineering plastics, as well as structural plastics. So what we're really dealing with is really just the left side. So unfortunately, single-use plastics, I would say, is a victim of its own success. The characteristics of single-use plastics, are so useful, but they're the same ones that have made them so problematic. So you have the ability to design plastics into desired properties and functions, which have made plastics so ubiquitous in so numerous applications. Their low cost and convenience have encouraged overconsumption leading to large amounts of plastic waste. And their low cost makes single-use plastic very often uneconomic. So the success of single-use plastic has also made them a problem. Now this is two graphs. The left side is the plastics that have been produced, and the right side are the plastics that are waste generated. And it's approximately 75% of all plastics produced go to waste. Now the average growth of plastics since 1950 is 8.5%, which means that every approximately every 8 years, we double the amount of plastic that we produce. The majority would be 6 polymers make up most of these plastics. Polyethylene, polypropylene, PVC, polystyrene, PET, and polyurethane. And many of these are single-use plastics. Now, the other thing I'd like to emphasize is that the shift to renewable energy means that we will be hopefully consuming less petroleum, but this will make single-use plastics cheaper because the petroleum manufacturers will now funnel a lot of these raw materials into plastic. So the trend might be single-use plastics should become cheaper, which will encourage more consumption. Now, about 75% of plastic produced is discarded as waste, and globally, only about 15% of plastics is recycled. So a large amount of these single-use plastic, and this is another type of classifying them, is packaging. And these are the types of plastic waste by type of polymer. So these are largely the 6 plastics that were identified earlier. And this one came out in the news last week. So Filipinos use more than 163 million plastic sachet packets, 48 million sando bags, and 45 million labo bags daily. So, well, that's the record for the Philippines. And this is the data which President Asansa just mentioned. So the Philippines has been ranked number 3 in marine plastic pollution, and it is mostly single-use plastic. Now this may be due to poor waste management, but also, of course, high consumption of single-use plastic. Now this is a document which the United Nations Economic Program, or UNEP, in 2018 came out with. And I'd like to just read some of the key findings and recommendations from this document. One of the recommendations is plastic is a big problem, so we should start with the most problematic. So they recommend that we start with single-use plastic. Second, the main problem appears to be a lack of enforcement, and 2, lack of viable and affordable alternatives. So if we're gonna have a law or legislation on single-use plastic specifically, we have to look into enforcement and look into viable and affordable alternatives. Third, should develop an appropriate multi-pronged approach, which may include bans, voluntary initiatives, financial incentives, and others. So it's not just, they say, you don't have to just depend on bans. There are other ways of addressing the problem of single-use plastic. Fourth, it has to be multi-sectoral. It just can't be top-down. We have to involve everyone. And then the program should be continuously monitored and be flexible to allow adjustment. In other words, if you're going to pass a law, it should be such that there's some flexibility in how the law is implemented. And finally, we should support R&D to develop new materials following the circular model of design and production of plastics. So that's the aspect where we need more R&D. So let's look at strategies for the management of plastics in general. Well, this is a familiar logo, reduce, reuse, recycle. It started around 1976 with a law in the US, Resource Conservation and Recovery Act. But the 3Rs has been criticized because it puts most of the responsibility on the consumer to reduce and reuse, while industry efforts to recycle have been insufficient. In other words, it's the consumer that bears a lot of the responsibility. So interestingly, the Europeans introduced the extended producer responsibility, where they put industry at the center instead of putting the consumer at the center. So the message being that industry has to play a bigger role in addressing this issue. So the producer's responsibility for a product is extended to post-consumer stage of a product's life cycle. And the extended producer responsibility was adopted as a policy by the OECD in 2001. It is applied to various products such as plastics and electronics. Now, so we go from the 3Rs, which is cradle to grave, and the grave happens to be the landfill. We try to minimize the landfill, so we have the circular economy, which is also a European model. And I've sort of proposed that we have extend from the 3Rs to the 5Rs, which includes a redesign of the material, reduce and reuse of the product, recovery of the product, and recycling of that product. So we extend the goals of what we want to achieve. Now, this is the description of the circular economy, the paradigm which the Europeans are proposing. So you start with a redesign of products using circular materials. And for plastics, this means that the plastic materials themselves have to be inherently recyclable. So recyclability has to be designed into the material. The sharing platform, reduce consumption by increasing utilization rates through collaborative usage or ownership. Third, product as a service. Producer retains product ownership, which all means extended producer responsibility as well. Product life extension, prolonged life cycle through reuse by repair, reprocessing, and resale. And then resource recovery, recovery and recycling of usable resources from waste and all byproducts. So, well, you can put the 5Rs there. It's actually quite consistent with the circular economy as proposed. Now, these are three measures which we should try to look at as we develop our strategy to manage plastics. One is we need socioeconomic analysis. Second, we need a life cycle assessment. And then here I'm going to propose some possible S&D projects. So for socioeconomic analysis, two of the things which we should look at, first is to mitigate the effects of bans on single-use plastic. So we shouldn't just start banning things. We should see consider the socioeconomic impact of that, especially the social, because if you're gonna impact, the lifestyle of poor people, you might, more difficult to implement the law. And second, economics of bans, the economics of bans on single-use plastics. So these should be studied beforehand. We should include a life cycle assessment of any decision that we're going to make. So our decisions must be science-based and be guided by life cycle assessment. So LCA is an essential tool for decision making. It provides a holistic picture of the entire product system covering natural resource extraction, manufacture, distribution and sale, use and reuse, waste management, and disposal. Now, life cycle assessment is also country specific. So you can't just copy the LCA from country X and say that's also good for the Philippines. And then LCA does not usually include long-term environmental impact. So now we have to input that into our life cycle assessment. By the way, this is a fairly technical topic. LCA, it's done by engineers. So I guess we need some expertise to do life cycle assessment. Now this is a life cycle assessment of bags versus plastic bags versus paper bags. Yeah, sorry. So this was prepared by the American Chemical Society. You have the polyethylene bags compared to paper bags, reusable non-moving polypropylene bags, and reusable polyethylene bags with 40% recycled content. Now, the more images you have on the table, that means the more the impact is. So you can see that the paper bags consume a lot of water. The reusable non-woven polypropylene bags consume a bit less, and so forth. But the bottom line here, the conclusion is that plastic bags in general have a smaller environmental impact than paper bags. But here they did not actually input the environmental impact. So this is an American, and usually LCA traditionally is not